Hello everyone, this is Marek Pavlos from NCmatic. Welcome in this week Technical Tuesday with NXCAM, the series full of practical tips and tricks about programming toolpaths in NX. Topic of this week is new CAM operation in NX, guiding curves. You might already know 5-axis version of it because it was introduced before, but 3-axis guiding curves, which I will present today, is new in NX 1202. What makes guiding curves special? It is that you don't need to care about projection vector. Keep watching and you will see how easy it is to create this operation. During this episode, I will walk through several use cases of guiding curves, showing you how it works on examples. And I will also compare it to other operations like Streamline and Contour Area. As I already mentioned Streamline, I've made an entire video about Streamline operation. If you haven't seen it yet, you should watch it. Link to this video is in upper right corner now. Let's start with first example. I will create guiding curves operation. It will be finishing cutting of this surface, which I'm selecting as cut area. And here's most interesting place, guiding curves drive method. It has 3 pattern types: constant offset, morphing, and racetrack around guide. In this case I will use morphing, so I must select at least 2 guiding curves. Here they are. And this is enough to be able to generate the toolpath. And we can see resulting toolpath is very smooth, and its shape is morphing from shape of first guiding curve, which was straight, to shape of second curve. It looks similar to Streamline, so let's compare it with Streamline. I will use fast forward during creating operations which are not new, but if you want to follow what I'm doing, you can slow down the video using this setting below. We can see that with Streamline operation, step over value is a little inconstant. And the default tool position is set to on. Let's try it with Tantu. With Tantu tool position, some part of cut area is skipped, so I will leave it with on position. In this case, guiding curves operation produces better toolpath than Streamline, and it's easier to create. I will compare it also with Contour Area operation. Obviously in Contour Area we shouldn't expect such nice morphing, and we will get straight zigzag. But it has one advantage, which might be useful in this case. It is excellent at edges. I don't see this option in guiding curves. Looks like it is not available in NX 1202. Let me know in comments below if in your opinion it would be useful to be able to extend the guiding curve toolpath. Or maybe it is possible, but I can't find it. As next example, I will create finishing operations for these surfaces. I will create guiding curves similar way as last time. And let's see the result. Toolpath looks very smooth. It doesn't have much unnecessary retracts and engages. The only drawback I see here is that it might be not the best idea to machine these steep surfaces in up and down direction. With guiding curves operation, we have really big influence on a final shape of the toolpath. You will see it in next examples in this video. Vertical motions in previous operations were caused by second guiding curve. That is why I will try to define this operation with just one guiding curve. And we can do this using pattern type constant offset. I like this toolpath more, but we can continue modifying it to get toolpath which will be more aligned with edges of faces. To keep the toolpath in more horizontal direction and aligned with shape of faces, I will split it to two operations. In first operation, I will use only one guiding curve and constant offset pattern. I will use cut order left to right, so toolpath will start at the top of these faces. Here is the toolpath of the first operation. It is worth mentioning that when you see the toolpath, keep in mind that it represents tip of the ball mill. Actual machining is in the point where the tool and part are in connect. For opposite side of this area, I will use two guiding curves. And here we have very smooth toolpath with consistent step over, with just one engage and one retract, and we didn't even have to bother with projection vector. Next example will be toolpath for these two areas which you can see here. As always, I will start with selecting cut area. this case, I will use single guiding curve, and I will use this circular edge for that. Also, I need to reduce step over and change cut order to machine from top to the bottom. And the toolpath is ready. It was very simple, you can't deny that. I will reuse this operation to machine second area. Similar like in Streamline, cut area must be contiguous. And it's ready. Do you think you can achieve such a nice toolpath with other operations? Let me know in the comments. If yes, I can send you this part file and you can try to do this yourself. Another two operations which I will create are example of how you can use guiding curves operation in repairing jobs. First, we must have an area specified where the material was welded. It can be done numerous ways. I will use Sketch for that, and I will draw an ellipse. And I will project this ellipse to part surface. Now I can create very simple guiding curves operation with constant offset pattern type. Here we have a smooth helical toolpath in the area which we manually specified. Second way to specify area where welding was done is to add a single curve. This curve also should be projected to part surface. And this is an example use case of racetrack around guide pattern type. As you can see, this way I created toolpath based on a single curve and propagating away from this curve with constant step over. As I mentioned before, this operation always takes contact point into account. That's why toolpath might look deflected a little bit, but this is caused by steepness of the face. This way, actual cutting will be done in the correct spot. I will move to next part file now, because I have a few more examples to try guiding curves. Here I will try to machine one of these pockets with smooth toolpath in a single operation. My first idea is to use external edge of pocket as a single guiding curve. You can see here some sharp corners at the toolpath. This is something what we usually want to avoid. Guiding curve settings, we have a part smoothing option, so I will use it. And yes, it added small radiuses to sharp corners. What I'm missing here is option to control value of this radius. I can't find it, so I assume that this is some hard-coded value. If you know something about this missing option, you know what to do. Let us all know in the comments. I will try to use another approach to create this operation. Because when I'm using only single guiding curve, Toolpath is not aligned with other faces. For example, it is not aligned with lower radius of the pocket. With more guiding curves, I expect I can align Toolpath as I want. And yes, but when I use morphing pattern type, toolpaths are created only between those curves. Here is one trick which you probably didn't know. You can also use point as guiding curve. It is possible also in Streamline, where you can use it as flow or cross curve. Now I will add my point as additional guiding curve. And the result is quite decent. Toolpath is aligned with lower radius of the pocket, and we don't have many sharp corners at the toolpath. Next sample operation which I will create is to show you one specific option. As external guiding curve, I'm selecting edges which are not even connected. Here we have a toolpath with a lot of engages of retracts. Obviously, we could expect it. And here is the option which I wanted to show you, cut sequencing. When it is set to by lines, at edges of part, we have engage and retracts. But when we will set it to by regions, we will get nice step-over moves at the edges. Now I will create operation to machine all faces in the middle of this part. Obviously, I will use morphing pattern type. I will create external and internal guiding curve and one additional in the middle to force toolpath to be aligned with edges of these small radiuses. Here is the result. I would like to compare it with regular streamline operation. I should also add a path smoothing for guiding curves operation. And finally, here we can compare both toolpaths. In this case, in my opinion, Streamline did a little better job morphing the toolpath more smoothly. In conclusion, guiding curves is very easy operation to use. Maybe not as easy as contour area, but quality of the toolpath generated with guiding curves is incomparably better. And comparing to Streamline, guiding curves is so much easier to create. You can forget about figuring out every time which projection vector could give better results. And at the end, I would like to encourage all of you, if you would like to see some specific topic presented in next Technical Tuesday episodes, let me know in comments below. And if you liked this video, don't forget to subscribe to my channel and share it with other NXCam users. All the best and see you in next Technical Tuesday with NXCam.